We have seen what are errors and different types of errors. Now we can see how will you represent an error. So there are three types of representing an error. Number one, absolute error. Number two, relative error. And number three, percentage error. Let the physical quantity measured values be A1, A2, A3, A4 and A5. Let 5 observations are taken and hence these observations are A1, A2, A3, A4, A4 and A5. First we have to take the mean value. A mean equals take the sum of all the observations divided by number of observations. Since we have taken 5 observations, therefore divided by first 5. Okay. Now how to represent the absolute error? Absolute error is the magnitude of difference between the measured value and the mean value. So absolute error of each measurement can be represented by delta. Delta A1. Delta A1 represents absolute error in the first observation, which is A1. So delta A1 is take the magnitude. This represents the take the magnitude. Even if it is negative value, take the positive value only. So that is delta A1 equals A mean minus A1. Similarly, delta A2, absolute error in the second observation, which is A2. Delta A2 equals A mean minus A2. Similarly, delta A3. Delta A3. Delta A3 is equal to again A mean minus A3. Delta A4 equal to A mean minus A4. Similarly, delta A5 equal to magnitude A mean minus A5. So this representation is called absolute error of each measurements we have taken. Now the mean absolute error is delta A mean equals delta A1 plus delta A2 plus delta A3 plus delta A4 plus delta A5 divided by number of observations. Okay, so this is the method of finding the mean absolute error. So first one, if observations are given, first you have to take the mean value, then find the difference between the mean value and each value, take the magnitude alone, then take the mean value, mean of all the absolute errors. Okay. This implies that the final result is reported as A mean plus or minus delta A mean. So this is mainly the numerical based questions. Okay, this type of derivations will not be asked, only numerical based on this will be asked. Okay children. Now second one is relative error. How will you represent relative error? So relative error is given by delta A mean. Delta A mean is the mean absolute error. Okay, so delta A mean divided by the mean value. This is the representation of relative error. So relative error equal to mean absolute error, that is delta A mean divided by the mean value. Right. Now the percentage error. How will you represent percentage error? Percentage error is simple, that is relative error into 100. Relative error into 100, that is delta A mean divided by A mean into 100 is called percentage error. Okay. You can do a question relating error. The diameter of a ball was measured as 5.27 centimeter, 5.30, 5.28, 5.32, 5.28 centimeter. We have to find out the mean value, mean absolute error, relative error, percentage error and express the result in terms of percentage error. That's a question. So first, how will you find out the mean value? Take the mean of all the observations. So we can write A mean. Any representation we can take. Here I am taking A mean. A mean equals 5.27 plus 5.30 plus 5.28. Okay. 5.32 plus 5.28. These are the observations given, divided by how many observations are there? 5 observations, therefore divided by 5. So if you find the mean value, it is found to be 5.29 centimeter. Okay, so first find the mean of all the observations. Next step is we have to find out. So first is over mean value. We have already calculated the mean value. Okay, so that's the first one. Then how will you find out the mean absolute error? First we have to find out the absolute error in each observation. Absolute error is usually represented by delta, isn't it? So absolute error in first observation, delta A1. We know it is, take the magnitude A mean minus A1. That's the formula, no? So A mean is 5.29 minus first observation is 5.27. So minus 5.27. Take the magnitude alone. So it is 0.02 centimeter. Similarly, we can find out delta A2. Delta A2 is 5.29 minus 5.30. That is 0.01 centimeter. Similarly, we can find delta A3, delta A4 and delta A5. Okay, so this is the absolute error in each observations or each value. Now we can find out the mean absolute error, delta A mean. Mean absolute error. How will you find out the mean absolute error? We know mean absolute error is delta A1 plus delta A2 plus delta A3 plus delta A4 plus delta A5 divided by 5. Okay, so the formula is delta A1 plus delta A2 plus delta A3 plus delta A4 plus delta A5 divided by 5. Substituting the values and simplify, you will get 0.016 centimeter. So now we can find relative error. Relative error is delta A mean divided by A mean, isn't it? Delta A mean by A mean. What is delta A mean? 0.016 divided by what is A mean? 5.29. That is relative error. If you want, you can simplify it also. Okay, then next one is percentage error. Percentage error. Percentage error is, we know percentage error is delta A mean by A mean into 100%. So that is 0.016 divided by 5.29 into 100%. And after simplification, you will get as 0.3%. Percentage error is always expressed in percentage. Okay. So this is the percentage error. So we got the mean value, mean absolute error, relative error, percentage error. And the last one is express the result in terms of percentage error. How will you express the result in terms of percentage error is, the method is A mean plus or minus percentage error. In the explanation I have given how will you express the final result in terms of the absolute error, that is A mean plus or minus delta A mean. Here in terms of percentage error, the final result can be reported as A mean plus or minus percentage error. This is a method of reporting the final result in terms of percentage error. That is, the final result is reported as, the final result is expressed in terms of percentage error as that is A mean. What is A mean here? 5.29 centimeter. Plus or minus, what is the percentage error here? 0.3. So 5.29 plus or minus 0.3 percentage. This much centimeter is the final result. Now we can do another question. We measure the period of oscillation for a simple pendulum. The readings are 2.63 seconds, 2.56 seconds, 2.42 seconds, 2.71 seconds and 2.80 seconds. Calculate absolute error and percentage error. Express the result in terms of mean absolute error. First we can find out the mean value, A mean. What is A mean? We can take the sum of all the observation divided by 5 observations are there. We can find out the sum. So 2.63 plus 2.56 plus 2.42 plus 2.71 plus 2.80 divided by 5. So it is equal to 2.62 second. That's a mean value. Now we can find out the absolute error in each observation, that is delta A1. Delta A1 is A mean minus A1, isn't it? So it is equal to 2.62 minus A1, that is 2.63. It is equal to 0.01 second. Similarly, we can find out absolute error in each observation. So we got delta A2 equal to 0.06 seconds, delta A3 equal to 0.2 seconds, absolute error in A4, that is delta A4 equal to 0.09 seconds, delta A5 equal to 0.18 seconds. Now we can find out the mean absolute error, that is delta A mean. Delta A mean is, we know it is delta A1 plus delta A2 plus delta A3 plus delta A4 plus delta A5 divided by 5. Okay, so if you take the mean value and it is found to be 0.11 second. That is the mean absolute error, 0.11 second. Similarly, we can find out the percentage error. So percentage error, we know percentage error is delta A mean divided by A mean into 100%, isn't it? Substituting 0.11 divided by 2.62 into 100, that is equal to 4%. Right, so we got mean absolute error as 0.11 second and percentage error as 4%. Now the question is, express the result in terms of mean absolute error. So the final result can be reported as, A mean plus or minus delta A mean. Because here the question is, we have to express the result in terms of mean absolute error. Therefore, we can write A mean plus or minus delta A mean. That is equal to A mean. What is delta A mean? 2.62 plus or minus, what is delta A mean? 0.11 second. So this is the final result expressed in terms of mean absolute error. Okay children.